Hello students, this is a continuation of arithmetic operation on intervals under the topic fuzzy numbers. Now here they have given that the interval A is a subset of interval E and the interval B is a subset of interval F. They are asking us to prove that when we take the sum of the two intervals which are subsets of E and F will again be a subset of E plus F. Similarly, A minus B will be a subset of E minus F. A multiplied by B will be a subset of E multiplied with F, and A divided by B will be a subset of E divided by F. This property is known as inclusion monotonicity. So now let us prove this. First let us prove that A plus B is a subset of E plus F. To prove that, first we should consider the interval A, which is A1 comma A2, and the interval B as B1 comma B2. Similarly, we have to consider the interval E, which is taken to be E1 comma E2, and the interval F is equals to F1 comma F2. So these are the four intervals. So first, now it is given that A is a subset of E. So A is a subset of E implies that, from this we can say that the interval A, that is A1 comma A2, is a subset of what is interval E? It is E1 comma E2. So now what does this mean actually? If we consider an interval, so suppose this is E1 comma E2. So this is the interval E1 comma E2. So A1 comma A2 is a subset of E1 comma E2. So it will be somewhere inside here. So this is A1, A2. So from this, what do we observe? We observe that E1 is lesser than A1. So this E1 is lesser than A1. So because this is a subset of this set. So E1, from this it implies that E1 is lesser than, or sometimes it may be equal to A1, and it also implies that A2 is lesser than E2. Okay, so this A2 is lesser than E2, is lesser than, or it may be equal to E2. Now let us mark this as some equation 1. Now next we shall it is also given that B is a subset of F. First we saw that A is a subset of E, using which we obtained this equation 1. Now in a similar manner we shall consider this B is a subset of F. So what does that imply? B a subset of F implies that, now what is B? Closed interval B1 comma B2. Now this interval is a subset of interval F. So that is closed interval F1 comma F2. Now here in the similar way, now here we have F1, F2, and this B1 and B2, this interval is a subset. So this may be B1, B2. So what do we observe? F1 is lesser than B1. Correct. So from this we get F1 to be lesser than or equal to B1, and B2 is lesser than or equal to F2. So let us mark this as equation 2. Now let us compare equation 1 and 2, and let us take the sum of these two equations. So for adding equation 1 and equation 2. So when we add, what do we get? First we have to add this and this. So when we had the left hand sides of the inequality, we get E1 plus F1 to be lesser than or equal to A1 plus B1. And then we have to add this and this. So what do we get? And A2 plus B2 is lesser than or equal to E2. Okay, A2 plus B2 is lesser than or equal to E2 plus F2. Now again, by using this method, that is, you can see that Suppose if this is E1 plus F1 and this is E2 plus F2, so this is lesser than this, so A1 plus B1 and then A2 plus B2. So this is an interval which is a subset of this interval. So we observe that. So this implies that the interval, closed interval A1 plus B1 comma A2 plus B2 is a subset of this interval, which is E1 plus F1, okay, comma E2 plus F2. Now by using the addition property we can expand this. This interval can be written as A1 comma A2 plus B1 comma B2 is a subset of E1 comma E2 plus F1 comma F2. But what is this interval? Capital A plus this interval is capital B is a subset of this interval. E1 comma E2 is the interval capital E plus F1 comma F2 is the interval capital F. So we have proved that A plus B is a subset of E plus F. So we are done with it. So we started with A to be a here A is a subset of E and B is a subset of F, and we have proved that A plus B is a subset of E plus F. So the addition property is proved. Hope you have understood this concept. In our next video we shall learn the subtraction property. Thank you.